Hello everyone, this is Miss Nemet again with 4.5 quadratic equations. This is the very first time that we are trying to solve quadratic equations, and on this video I will show you how to use graphing utilities, different ways, computer, iPad, as well as GeoGebra. The objectives of today's lesson is to solve quadratic equations by factoring and to solve quadratic equations by graphing. And it's very important that you understand that the zeros of a quadratic function in the form of y equals ax squared plus bx plus c is when you put this equation equaling to 0 and solve. So you have to see that it is going to be the same. The x-intercepts and the solutions are actually the same. So the zeros of the functions, when you solve, is the same as the x-intercept. You can see here is a 0 and here is a 0. Every 0 is a solution. The objective here is solving a quadratic equation by factoring. You are given an equation, x squared plus 3x minus 18 equaling 0. So the objective is to solve a quadratic equation by factoring. The quadratic equation is x squared plus 3x minus 18 equaling 0. Now, factoring, so I need to find two numbers that multiplies to be negative 18, so the product is negative 18 and the sum is 3. Obviously, the two numbers are negative 3 times 6 is negative 18 and negative 3 plus 6 equals 3. So the factored form is x minus 3 times x plus 6 and the equation is equaling 0. Always FOIL it back to make sure that you check whether your factorization is correct. This time, yes, it checked out. I can continue. Using the zero product property, either this or that needs to be 0 in order for their product to be 0. So either x minus 3 equals 0, then x equals 3, or x plus 6 equals 0, so x equals negative 6. List the solutions in a brace, and then check your answers. So plug in both answers into the original equation to make sure that you have gotten the right answers. Solve a quadratic equation by GeoGebra on the computer. So what you have to do is, although GeoGebra would take the equation just like it is, and that's how I punched it into the input line, it then simplifies it. So it subtracts the x and adds 4. So what you have to do is find the intersection of the parabola and the x-axis. And GeoGebra gives you back those 2 points. These are the zeros of the function. To put this equation into your graphing calculator on your iPad, GraphCalc HD, you need to subtract the x and add the 4. So you punch in 10x squared plus x minus 42, and then press save. What comes out then is a beautiful function. Now you want to find the intercepts. So you press trace, snap to intersection, and then you touch it with your little finger. As soon as you touch it with your little finger, it finds the root. You see, this is a beautiful root, x equals 2 and y equals, of course, 0 because that's the 0 of the function. But when you try to find the left root, it doesn't find perfectly because this is not a whole number, so the computer has a hard time finding the root, but this is close enough. I mean, it's to the negative 14th power, so this is the 0. It is around 2.1. You can also use the table function of your graphing calculator. So next to y equals, here is the little list, and as you press that, it is going to come up with this table, and then you can find the 0. You can again just find 2. The other one is harder to find. You would have to change the increment to 0.1s, then you would be able to find the negative 2.1 root also. This is solving a quadratic equation by using GeoGebra on the iPad. So I got another equation. In order to graph that, I have subtracted the 18x, so it is going to be equaling 0. And the GeoGebra then shows you 5x squared minus 18x minus 8. What you do, just put that into the input bar, press enter, and then you have the graph. All you have to do then is find the intersection, and with your little finger, you will just touch the intersection of the x-axis and the parabola, both sides, and GeoGebra will give you the two intersections or the two zeros of this function. Easy, is it not? So if you want to solve a real-world quadratic equation, you have to be very careful. You need to read the entire question. So you're throwing a ball, and it is going to fly following the path that can be modeled with this equation. How far does the ball travel before hitting the ground? If you graph this parabola, this is an upside-down parabola, so the ball will fly from this point all the way to this point. Now, I assume that I'm throwing it from the ground and it lands to the ground. So how far is the x-axis? You have to calculate from here to here, which means the two zeros of the functions. So how do you find the zeros of the functions? You make the equation equal to 0, and then factor it, and solve both parts. So negative x equals 0. Of course, there is a 0 at 0, 0. And the other part is 0.002x minus 0.77 equals 0. So x equals 385. The answer is the ball is traveling 385 feet, in feet. So 385 feet before it hits the ground. I'm going to write feet here so we know that is going to be the correct unit. Now, what happens to the other question? How high does the ball go? Obviously, we need the y maximum value. So we need to find the vertex. Where is the vertex? The x-coordinate we can find by negative b over 2a. That is at 192.5. This is the x-coordinate of the vertex. And then how high will it go? I plug 192.5 back into the original equation, and I get that it will go approximately 74.11. So the height is 74.11. Now, what is the reasonable domain and range for such a function? Obviously, parabolas have domains of all real numbers, but we're talking about the ball flying, so it's not going to go underground. Not here, not here. So the reasonable domain is from here to here, which is from 0 to 385. I include the 0 and the 385. Please note that this is in interval notation. I'm using a bracket because 0 is included into my domain as well as 385. So that number is okay. When I say is greater than or equal to, so this means it's equals to and equals to 385 also. What is the reasonable range? As I said earlier, we need the vertex, and the range is from here to here, from 0 to 74.11. I just left that out. I rounded it to the nearest 10. Again, 0 is included, so it's a bracket, as well as 74 is included, so it's a bracket also. There is no parabola above this point, and it doesn't make sense to talk about negative numbers because we're talking about the ball. Real-life applications work in positive realm in most of the time in the first quadrant. So this was how to use your graphing calculator, GeoGebra, on your iPad. I hope that it was very beneficial. Again, if you need to listen to it several times before you might be able to use it on your own. Just try again and again.